The second video, exploring the Pythagorean relationship. So as we learned last time, a square is a number multiplied by itself. So for example, the square of 5 is 5 times 5, which is equal to 25. That's the square of 5. The square root, if we went backwards and took the square root, as we saw, of 25, then that answer would be 5. And in relationship to squares and side lengths, we kind of saw the square as the area and the square root as the side length. And that will become very apparent in this video here. So next thing we move on to is the right triangle. So a right triangle is a triangle, symbol just means triangle, with a 90-degree angle. So for example, we could write a right triangle like this. And a 90-degree angle is usually denoted with a little square on the side there. And that means 90 degrees. They can be drawn all sorts of different ways, right? Like this, with the 90 degree up in the top, or like this, with the 90 degrees over in the corner, or they can be written on an angle, drawn in all sorts of different ways. As long as they have that 90 degrees, that little square, which means 90 degrees, then it's a right triangle. A right angle is a 90-degree angle. So for the first activity I want you to do, and we're going to have to pause the video if you want to participate in the activity. So we're going to draw a right triangle with legs measuring 6 and 8 units. Then we're going to determine the length of the hypotenuse by drawing a square attached to each side. So what I do is I draw a little triangle here. I'm just going to represent it like this. There's a right triangle. We have side lengths measuring, or legs, which are these ones, 8 and 6. And then the side over here is called the hypotenuse. That is the longest side of a right angle triangle, hypotenuse. And that's what we're going to try to find. That's the whole point of Pythagorean theorem, is to find the length of the hypotenuse, or in a right triangle, finding the lengths of one of the legs. In this activity, we're going to find just the length of the hypotenuse, which again is that longest side. We're going to do that by drawing a square attached to each side. So if you want to pause the video now and you want to try to draw the squares, find the area of the squares, then draw a square on the hypotenuse and try to figure out what do you think the area of that square would be, because we know we're going to add all the squares of the legs together, and that area added together, if I add them together, the area is going to be equal to the area of the hypotenuse. So try that now. And we'll move on. So if I build a square off of each side, I'll have a square. I'm not going to draw these to scale. A square like this with side lengths 8 and 8. So the area of this square will be 64. And if we call this, let's call these inches. The 64 would be in inches squared. Building a square off the bottom here, be a little bit smaller. And I have side lengths of 6 inches and 6 inches. So the area of this square would be 36 inches squared. Again, be very careful with your units, using squared for area. And if I'm building a square off the hypotenuse, this is going to look like a rectangle, but we're going to build the square. What I do is I add these two areas together. So I have 64 plus 36. I add those two values together. 64 plus 36 is equal to 100. And that will be the area of this square built off the hypotenuse. Again, that's in inches. I'm going to get rid of this hypotenuse here. That will be in inches squared. And to find the side length, remember how to find the side length of a square from last video? I just take the square root. And the square root of 100, you could use a calculator, but the square root of 100 is actually 10. So I have 10 inches and 10 inches. So the side length of the hypotenuse, this side here, is going to be 10 inches. And we found that using building squares off of the sides, understanding the relationship between the area and the side length, and then solving for the side length by taking the square root. So the conclusion, the sum of the areas of the squares attached to the legs, remember the legs are not the hypotenuse, the legs are the other two sides, is equal to the square attached to the hypotenuse, which is what we just showed above. So just be aware of that. So last example here, or one more example. Determine the area of the squares on the sides of the on the three sides of the following triangles. This is going to be just another exercise of building these squares. We have the side length this time. We're going to be drawing these squares and then figuring out what the area of each square is, given the side length. So I know that this leg over here on the left, the side length is 4, and all the sides are going to be 4. So 4 centimeters, 4 centimeters. So the area is 4 times 4, which is 16 centimeters squared. The area on the bottom one is 3, the side length is 3. So all the side lengths are going to be 3 centimeters. So the area is 3 times 3, or 9 centimeters squared. Now the area of the third one should be these two areas added together. So if I took 16 plus 9, which does equal 25, and I know the side length of this hypotenuse is 5, which means all the side lengths are going to be 5 centimeters, then the area is 5 times 5, which is 25 centimeters squared. So this kind of proves what we were trying to show before with the areas taking the square root or squaring it this time to find the area of the square. And the addition, the sum of these two, the 16 and the 9, will equal the area of that third square built off the hypotenuse, just to really drive that point home. Okay. Similarly, if we didn't build the squares, you could just, in fact, take the area, so without dealing with all the numbers, getting rid of the areas, we could show that 4 squared plus 3 squared, and again, those are the areas of those two squares, is going to be equal to 5 squared, which we showed. We said 16 plus 9 is equal to 25. Okay, and this will become very apparent right in the next section here. So, next example, last example, determine the length of each side. And we're going to ask, is the triangle a right triangle? So is it, in fact, if I add these two areas, is it going to equal this area here? Okay, so determine the length of each side. Again, we take the square root of each one. You can use your calculator if you want to. Whoops. And we'll show that 900, the square root of that is 30. So these side lengths are 30 meters. 1600, I know already is 40. So that's going to be 40 meters. And 2500, the square root of that one, that's a big one. So 2500, take the square root, is 50. So 50 meters for the side length. Notice I started off with the area, which was meters squared, and I went to the side length, which is just meters. So I found the side length of all of them, and I can check for the areas of the two legs. So I have 1600 plus 900. And you can do that in your head, or you can use a calculator if you would like. 1600 plus 900 is, in fact, 2500. So, yes, this is a right triangle. And what I could do is I could say, because I checked, you know what, now I can put that little right triangle, or that right angle in the corner. So, in conclusion, the Pythagorean relationship is written like this. A squared, which is the area of the square built off one leg, plus b squared, which again is the area of the square built off the other leg, is equal to c squared, which is the area of the square built off the hypotenuse. We always use c for the hypotenuse, so there's no confusion. We always use a and b for the other legs, but c is always reserved, always a special letter for that denotes the hypotenuse. So hopefully that gives you enough information for this section. Go on to the assignment, and I hope you do well.